everyone, this is a video that's going to show you how to write the equation of an exponential function if you're given 2 points. So you already know how to write the equation of a line given 2 points. You use mx plus b. If you want to write the equation of an exponential, what we're going to be using is the base formula for an exponential equation, y equals a times b to the x. And I just discovered my computer has these amazing multicolored pens, but I'll go back to a normal one. Okay, so like I said, we're going to be using this here as our building block. We haven't exactly done this skill in class before. There's 2 main types that you're going to need to know how to do. One of them is whenever the y-intercept is already known, and that is going to make it significantly quicker to do because in that case, you'll already know a, because remember, a is the y-intercept or the initial value. In both cases, whether you know the y-intercept or not, you're always going to find b, which is either the growth or the decay factor. All right, so there's not really any notes. It's just examples so you can see the different types that you're going to be seeing tomorrow. All right, let me scroll this thing up here. Oh my God, get up there. Okay, let's start with the ones where you're given, let's say, a graph and the y-intercept is already known. These are the ones that are the quickest to do because you just look at the graph and you're going to look for what type of growth or decay you have. Now remember, if you have a line and you have a constant rate of change, you'd be looking for what you add to go from y to y. But if you have exponential, then what you're looking for is what do you multiply by to go from y value to y value. Sometimes it's very straightforward. Sometimes it's a fraction. So in this case, you're going to look at your graph and right away I can pick out my y-intercept. So this is my a value of 3. And I'm just going to look at my graph for some points that I know are definitely on this curve. So that's why I put like 1, 6, 2, 12. I just picked them right off the graph. If you look at a graph, you don't ever want to assume that like this is 1.5, for example, because you're not 100% sure. So that's why I didn't put it in the table. But I don't need it because to go from 3 to 6, I multiply by 2. To go from 6 to 12, I multiply by 2. That is a constant growth factor right there. You're doubling. So in this case, it would be y equals a b to the x. So y equals 3 times b is whatever you multiply by to jump from y value to y value. So 2. What about this one here? I definitely have the 0.08. I definitely have the 0.1, 2. And we do have another point here, but let me get my pen here. I mean, this kind of looks like 1/2. Let me see if the pattern still holds. But these 2 I'm definitely sure on. So you're going to use the same rule that we just did before. What do you do to go from y value to y value? To go from 8 to 2, we divide by 4. To go from 2 to 1/2, you do divide by 4. And this rule of like, oh, what do you divide by? That only works for sequential x values. That means like it has to be from 0 to 1. You don't want to go from like 0 to 4 because then you'd have to do some more math here. In this case, if your x is just changed by 1 and your y, you divide by 4. But you don't want to think like what you necessarily divide by. You want to think what you multiply by. So dividing by 4 is the same as multiplying by 1/4. So when you write this thing out, a times b to the x, your y-intercept is 8. B, what you multiply by to go from y value to y value, which is 1/4 to the x value. Okay, so let's try one more like that. Here. Okay, what if I have this graph? So this is decay. I'm expecting a b value less than 1. I have a y-intercept of 1, so not much to do there. I have the 0.01. Okay, I have -1, 3. And this one looks obvious. It's -2, 9. So to go from y value to y value, I divide by 3. To go from 3 to 1, I divide by 3 again. But you want to do, what do you multiply by? So you multiply by 1/3. You multiply by 1/3. So that means b is 1/3 is what you multiply by to go from one to the next. Okay, let's try some where there's going to be a little bit of work involved. Let's take a look at these where I have 2 values and the difference is my x's don't just differ by 1. I'm jumping from 0 all the way to 5. And my y values aren't as straightforward. Like I have 4 and 600.25. So that one's not going to be as simple. And we're going to probably have some decimals here. So we know this is an exponential curve. It tells us that. We want to find the equation. Since I already know the y-intercept, half the work is already there or already done. So I know that I start with 4, so I'm going to plug that in. And what we're really looking for then is b. I already know a. I'm looking for b. It'd be nice if I had an xy to plug in. So all you're going to do is take another point on the line. In this case, just use what's given. So I'm going to plug in 600.25 for y. And then I have 4 times b. I don't know b. I'm looking for b. Plug 5 in for x. Once you do that, you're just solving your equation. So let's finish off these last steps. I'm looking for b, so I'm going to divide each side by 4. 600.25 divided by 4 is, I already did that out, 150.0625. And then I have b to the 5th. Okay, in this case, I'm looking for my base. My exponent is a number. So in order to undo to the 5th power, we did this a month ago, you're going to do the 5th root. The 5th root of something to the 5th power cancels. Okay, and the 5th root of 150.06 is 2.724. So that means my final equation is y equals a times b to the x power. All right, let's take a look at another one right here. So we have a times b to the x. I'm given an a value already of 3. I'm going to use the other xy that they give us. So y is 1/2. 3 times b to the x. X is 4. All right, I'm looking for b again, so let's get rid of the 3. 1/2 divided by 3 is 1/2 times 1/3, which is 1/6. B to the 4th. In order to get my base alone, which is like my unknown variable, I'm going to do the 4th root and the 4th root here. Just to make sure you remember how to do a 4th root, I can hit 4, go to math, and go to the xth root of 1/6. 0.639. Let's round it to the 3rd. So 0.639 equals b, not x. All right, so y equals my initial value. My b value is less than 1, which is good. It should be less than 1 because I have decay. My b value here was greater than 1 because I had growth. All right, so those are if you already know the y-intercept. What if you don't know the y-intercept? In that case, you have to find a and b. So let's take an example here. I'm just going to give you 2 points, and we're going to find the equation. So you have 1, 3, and you have 2, 4.5. If you just think about like 1 is at 3 and 2 is at 4.5, you should have some type of growth. So b should be bigger than 1. Your a value is probably going to be bigger than 1 as well. So you want to think about those things so like your answer makes sense. All right, let's plug into y equals a times b to the x. You're going to plug in y equals a times b to the x for both ordered pairs. So let's plug it in for 1, 3 first, because like you don't know a or b, so you need both ordered pairs to find it. So, okay, I'm not going to put y in. Let's put 3 in for y equals a times b to the x. X is 1 here. And then y equals a times b to the x. So usually what you're going to do is you have 2 equations here and you have 2 unknowns, a and b. Elimination doesn't, I guess you could do elimination here, but you don't really want to subtract. It doesn't necessarily work the same as it did before when we did elimination with lines. In this case, your best bet's probably going to be substitution. So I typically will solve for a. So if I want to get a alone, I'll divide each side by b, because b to the first power is just b. So a is 3 over b. So then let's continue solving here. You have 4.5 equals a, which is 3 over b, times b squared. That means 4.5 is, okay, 3b squared divided by b is just 3b. That's just using properties of exponents. And then divide by 3. 4.5 divided by 3 is 1.5. All right, you still have to find your a value though. A was 3 over b. I'm getting that from here. Okay, so I have 3 over 1.5, which is 2. Your final equation is a times b to the x. You're not done until you actually have an equation written down. This example is a little bit different because neither b value ends up having just an exponent of 1. So you're going to do a little bit more exponent simplifying in this case. Once again, I'm going to take one of my equations and solve for one of the variables. You could solve for this a and plug into here, or you could solve for this a and plug in for here. It really doesn't matter. I'm going to go ahead and get this a alone. When you're doing it on your own, you can definitely choose like which variable you want to get alone, but you have to solve for one of them so that you can plug into the other equation. So I just divided each side by b to the negative 2. That cancels, and I'm left with a. Okay, so now I know that a is 6 over b to the negative 2. Let's plug it into that equation there. So I have 1 equals 6 over b to the negative 2 times b squared. So 1 equals, okay, there's a couple ways to do this. You have 6b squared, to make sure those don't look the same, 6b squared over b to the negative 2. I'm going to go ahead and move this up to the top. So it'd be 6b squared, b squared. You definitely don't have to write like all these steps out. I'm definitely writing more steps than you probably would, but just to make sure you're following along. I'm going to keep trying to get b alone. So in this case, I'm looking at the 4th root of 1/6. And when you do that on a calculator, so I went on the graphing calculator and typed that in. So 6 divided by the 0.639 to the negative 2 power. And our a value is 2.449. That's our initial value or our y-intercept. So your final equation, you're looking at 449 times 0.639 to the x. All right, tomorrow you're going to be doing problems at the board, and some of them are going to have some decimals, so I just want to make sure you're going to be okay setting it up with the decimals. I'm going to have this one already kind of written out here because it's the same setup process. So pause the video for a second and get caught up to this point. I have it pre-written just because the first steps are the same we've been doing. I just wanted you to see an example done out where the numbers are not quite as friendly and we have some decimals because we're going to be doing some problems that are like the application based where there are more decimals. So same steps as always, you plug in your two ordered pairs, you solve for one of the unknowns, A or B, in one of the equations, plug it into the other equation and continue solving from there. So I have 0.94593 equals, I'm going to plug in my A value, 7.2485 over B to the 4th and then B to the 15th. And then you're pretty much always going to do your properties of exponents. So 0.94593, 7.2485 B. So I'm going to subtract my exponents because I have B to the 15th over B to the 4th. That would be B to the 11th. All right, so what I did here is I combined those. I got b to the 11th. I isolated to get b to the 11th alone, and on the calculator, whenever you do this, I just divided those two. I got here 0.131 or 0.1305. I'm going to do the 11th root. You're pretty much always going to end up doing a radical here, and you have the 11th math 5 root, and you can always do second answer, so you don't have to type that in again. 0.831, I'll round it like that. 0.831 is B. And then you're just going to plug back in to here to get your A value. You'll plug in what you got for B. And in case you want to see that out, I'll jot that down. All right, so I just plugged into my equation here. I plugged in for B, what we found above, and I got my A value. So I start with a y-intercept of 15, and on the graph, it does look like 15.2, so that should make sense. All right, cool. We'll practice this in class, and have a great day.